So what we would like to talk about today is several things. So first of all, why would you choose Kaa? Why would you choose Cassandra and why Zeppelin? After we go through these, we would like to cover the architecture of a sample application that we'll be showing today, and we'll go through a hands-on experience of setting up a Kaa Sandbox, walking you through the application code for the client based on Intel Edison that will be submitting data to Kaa-based cloud. We will also review the configuration for the Cassandra appenders and how we will be feeding this data from sensors into the database. We will also hook up Zeppelin to Cassandra and make it read data from Cassandra in real time, and we'll go through a live demonstration of the data visualization with Zeppelin. Once again, if you have any questions, feel free to ask them at any time. We'll try to get them addressed either right away or in the end of the webinar. So for those of you who wonder what I was talking about when I was saying like Kaa 080 and Avocado Archipelago and so on and so forth, 10,000 feet view on Kaa. So Kaa is essentially a middleware platform which lives between the two worlds, the world of hardware and the world of applications. The hardware can be pretty much anything, just as the application that Kaa enables you to build on top of it. So what Kaa does in these setups is it handles data streams between the physical hardware, between your applications in the hardware and the backend logic. Why would you choose to build a system based on Kaa? So first of all, Kaa is fully featured IoT middleware platform that is also 100% open source. Both the server and the client components are open source with Kaa. So that enables you to deploy Kaa-based systems pretty much anywhere. You can have them installed on premises. You can have them installed in facilities, in factories, in airports, anywhere where you cannot afford sending data up to the public internet, to the cloud. However, you can also deploy Kaa-based applications in the cloud environments, or even consider using a hybrid mode where you would have a core cluster that would be in your data center, and that would scale up into the cloud as the demand increases and scale back to your data center as it drops. So in order to enable that, we built Kaa to be horizontally and elastically scalable. So this is a very modern platform that has no single point of failure, and you can deploy more servers as you see more demand. When it comes to specific applications, what is important is that Kaa guarantees telemetry data delivery and also reliable storage of the data and consistency of the data that you collect from your IoT devices. It has built-in transport security mechanisms so that all of the data that is transferred from devices to the cloud and vice versa is encrypted and protected with the FIPS-compliant algorithms. It serializes the data extremely efficiently. Under the hood for all of the communication, Kaa uses Apache Avro, so that provides us with a very efficient way of sending the data over the network. It enables you to develop applications very rapidly with several SDKs. So it's C, C++, Java, and now Objective-C SDK coming in 0.80. With the C SDK, the footprint of the minimalistic application does not exceed 10 kilobytes. So that is suitable even for the smallest of devices. And you can see quite a few of those on this slide at the bottom. So now quickly about Cassandra. Cassandra is a good choice when you're looking for a fault-tolerant and highly scalable and also high-performance solution. It is easy to deploy because it's it's a uniform cluster, and it has integrations with various popular analytics platforms like Hadoop, Spark, and can be deployed in mazes. Now, Zeppelin is, well, when we found Zeppelin, it was a revelation. We actually liked it very much. This is, Apache Zeppelin is actually right now a project that is undergoing incubation in the Apache community. So expect some issues and bugs along the path, but generally Zeppelin is extremely good and promising project for visualizing data, especially useful for the data scientists who do not hesitate to write some code and some SQL queries and so on and so forth, and build visualizations really rapidly. It integrates perfectly with Apache Spark, so that means that you can basically use pretty much any data data store system, database that is integrated with Spark. Zeppelin enables you to build queries as you go in a web-based application that can also be shared similarly to Google Docs or similar systems. And it also enables you to have multiple people collaborate on the same spreadsheet or the same document. So this is where I will ask Andrei to continue with the demonstration of the application, and he'll walk you through the rest of the webinar. Enjoy.
Hello everybody. Let's continue to the hands-on part of our webinar. So let's start from the problem description and what we are going to build, or what application we are going to build right now. So let's assume that we have different solar panels in multiple zones, and each zone may have multiple solar panels. And we are going to collect this data and do some data visualization and basic analytics in Apache Zeppelin. So let's proceed to the reference architecture. Let's review the reference architecture, and I will try to answer some questions that was raised during the webinar. So in our case, we have a Kaa cluster, and this cluster supports and handles requests from Intel Edison-based applications. So the Intel Edison application collects raw data from the solar panels about the amount of power that is produced, and then it push this data using Kaa SDK to the Kaa cluster. And Kaa SDK is transferring not raw data but the structured data to Kaa node. Once data is transferred to Kaa node, we have set up the Cassandra appender that will push this data to Cassandra. Cassandra appender and all other appenders that are implemented and supported by the platform have ability to guarantee data delivery. And in case of any data delivery errors, the error is pushed back to Kaa SDK, and basically it allows you to store, the Kaa SDK stores data locally while data is being delivered. As soon as Kaa SDK receives confirmations that data was successfully delivered to Cassandra or to any other data storage, it basically deletes a local copy of the data. In case one node goes down, Kaa SDK switches and connects to the other node and delivers data through the other node. There is no single point of failure in Kaa cluster, so Kaa cluster is always operational if you have enough nodes and if they are geo-distributed into different zones. Once data is pushed into Cassandra, we will use Zeppelin instance in order to build several dashboards and visualize this data. Let's proceed to and navigate to the GitHub repository where we have our project and installation instructions for the project. So this is a sample project that contains client-side code and a full instruction how to set up this demo and how to get it working with Kaa Sandbox 074. In order to run this demo, you will need Kaa Sandbox, and you will also need to upgrade Cassandra instance on this sandbox at least to version 2.2. This is related to our intent to use some custom functions for our table, and in order to improve Zeppelin functionality. So we will use two functions, time format and time delta, in order to be able to format the output and in order to be able to visualize sliding window, time window. So once you get done with Cassandra configuration, and it is quite simple, you can proceed to working with the sandbox. Let's open the sandbox page. So the sandbox is basically a setup of Kaa cluster, single node cluster with a lot of applications pre-configured. There are applications for different platforms and for different that show different platforms and different features. There is also a level of complexity of the application, so you can start by filtering basic applications and build and run some demo on Java or on Android or on C or C++. There are different instructions for C and C++ code how to build it for specific platform. For example, for Intel Edison or for Texas Instruments or other. You can find all these instructions on our website by navigating to the documentation page. So our today's demo will be based on data collection demo. So I'll go to administration console and we'll see how it looks like. So let's open the data collection demo, and what we're going to do is to set up this sample application is to add new data schema, which is called Power Report. I've previously downloaded the source code from the GitHub into the folder. So in order to add the schema, you just click on Add Schema and navigate to the folder where you downloaded Sandbox, and navigate to source main resources and open this log schema file. Once you open it and upload the schema to the server, you are able to review and name the schema. And let's review what fields are we going to push from the client application to the server side. So there are 4 fields. One is timestamp, second is zone ID, which basically identifies our geolocation zone. And there is also a panel ID that identifies a concrete panel inside of the zone and the amount of power produced for a certain time interval. I already added this log schema, so we will use, as you can see, this schema version is 4.0. So now in order to push the data using this schema, we are going to generate an SDK, and you're able to choose different platforms, and we will choose Java platform and generate a Java SDK. I'm going to save this SDK to our working folder, and there is a folder called library, and you should save this as a Kaa client SDK.jar. Now we are able to run the sample application, but before we will run the sample application, I want to demonstrate a log appenders page where we configure where we want to push this data. And we basically have 2 log appenders. These appenders are both of type Cassandra, and they push the same data into different column families in Cassandra. This is used in order to Cassandra data modeling leverages data deduplication in order to speed up certain queries, so that's why we set up several appenders to push data to different tables. Let's review one of the configuration. So inside of Cassandra log appender configuration, you're able to specify different Cassandra nodes where you want to push the data. Key space name, table name pattern, and basically the column mapping between the event fields and the column family fields. We will, in this case, we will have a zone ID as a partition key, and we will use timestamp and panel ID as a clustering key. Please note that you're also able to push event in the binary form or in JSON, or you're also able to use header fields. Header fields are endpoint key or version of the header or timestamp that is present at server-side timestamp or application token, etc. The most useful is endpoint keys that basically allow you to identify the instance of the application that is pushing the data. Using this endpoint key, you're able to push back notifications on configuration updates based on certain results of analytics. So let's go to the console and build our application and start it. So application now started and it's pushing data. So this is a similar to applications that push data from different zones, but you're able to build application based on different other sample applications for Intel Edison or for any other hardware platform that is supported. All these applications will work with same data structure and will be the same from the server point of view. They will just use different SDK source code. Let's now navigate to the Zeppelin page. And here in Zeppelin page, you see several dashboards that we provisioned. I will talk a little bit later how to do this. So we have a historical power panel. This is historical dashboard that shows two charts. First one is shows the amount of power produced in each zone, actually in one zone that you're able to configure. The second chart shows amount of power produced in a particular zone, in particular panel. The other dashboard is real-time power per zone, and this application works similarly. So let's refresh this page. So it basically works on the same data, so it should be loaded in a second. Yeah, so this actually happens from time to time with Zeppelin, especially when the computer that is hosting Zeppelin is low on resources. Zeppelin is able to recover in certain period. So while it is going to recover, we can review the source code of the client application and what API you could use to push the data. So the source code is pretty simple, and what it does is basically using Kaa client, which is an interface of Kaa SDK. So this here we create the Kaa client, and we basically have a state listener that allow you to listen when the Kaa client is started and when it is successfully stopped. Then we are going to set log upload strategy. And in our case, we are using one of the predefined log upload strategies that allow you to push data as soon as one record is in storage. This means that, for example, if you will push 10 records, we will generate 10 requests to deliver data. This is not very efficient in the real-time application, in real-life application. And in the real-life application, you can push data, for example, periodically once per minute or once per second, or when you get 100 data points collected, etc., etc. So all this present is, and you can use different log upload strategies that are already available in SDK. One of the options is, by the way, to push data once you get 10 or 100 records. But in case you're collecting data for more than 5 seconds, you will automatically push everything you got. And finally, the client is stopped when you stop the application. Let's go back to the Zeppelin, see what is it able to recover. Oh, it is right now disconnected, so I think it is still recovering. Let's wait a little bit more. Do you have any questions? If you have any questions, feel free to post them, and I'll try to answer them before we have. There was a question about timestamp data. Yes, you're basically able to push timestamp data or any other data that you'd like. We use efficient data serialization framework to deliver data in compact way from the client to the server, and you're basically able to define your own data schemas using Avro, Apache Avro definitions, or using web user interface. So you just click Add Schema, and oh, I believe the server that we're using is experiencing some problems. Okay, anyway, so you're able to use web interface in order to define any data structures that you would like. So there is a question about, does Kaa SDK do the ETL from raw data to structured before storing to Cassandra? Yes, this is actually possible. You're able to use your appender and you're able to configure what data and in what format you want to push. You're also able to customize appender implementation and do some more intelligent processing. Often people use something like pushing data as a raw data to Cassandra and analyzing this data and transforming it with Spark, and then basically reducing the amount of the volume of the data and providing some efficient data structures. And once data is ready, it can be visualized not only with Zeppelin, but also with other tools, and you're even able to push data to SQL database and analyze it with more traditional tools. There is also a question, can we configure Kaa SDK to define the sensor data calculation before sending to Sandbox? Yes, this is possible. You're basically able to configure your application using Kaa configuration feature and to define algorithms and pre-processing rules and deliver this data to your application. Once your application is configured, you're able to apply some formatting or apply some transformations before you push the data. There is also a question about, let's say I have a million of data points and I want to do a complex aggregated query. So for example, average, summary, deviation, group by, etc. How long such a query would take to return? So this is actually depends on your hardware, and it also depends on the complexity of the query. In such case, I would recommend to use Spark SQL as a most scalable solution that we've experienced. You're also able to push data to Hadoop and analyze it with traditional like Hive or something like this. So there is a built-in support of pushing data using Flume, and you're able to analyze data with Hadoop. So it looks like our Zeppelin is back to life. So let's review statements that we've used in Power Panels. So there is a statement where we used several functions like time delta that we've customized. So in our case, we just select zone ID and panel ID and do some basic transformations with timestamp and order it by timestamp. There is also a question, is a Docker version of Kaa available? Yes, we are working on the Docker version, so it's now in development, and basically we have custom implementation and some deployments. I think this is it for now, so if you have any other questions, please feel free to post them. There is one more question. So the question is, there some example in C++, Java ready to use in Raspberry endpoint? Yes, there are questions, and then basically for Raspberry you can build both Java, C, and C++ applications that we use in our Sandbox. You just download the source code and you're able to click on open the documentation page. And here in the documentation page there are supported systems and hardware platforms. So you can open Raspberry Pi and you will have basic and complete instructions on how to install third-party components for C and C++ SDK. There are plenty of instructions how to install Java on Raspbian. And that's basically it. Once you will install third-party, you just download sample application from the Sandbox and do the build quite easily. So this is it for today. Thank you very much for your attention. I hope you enjoyed this webinar and you will be able to use it in real life applications. Thanks.